In this video, we're going to look at two velocity time graph questions. So the first question states that two cars, A and B, leave a point P at time t equals 0 from rest. Car A accelerates for 10 seconds at a rate of 2.5 meters per second and then continues its journey at constant velocity. Car B accelerates for 25 seconds and reaches a constant velocity of 28 meters per second. Car B overtakes Car A at the instant both cars pass a point Q. Part A asks us to sketch a velocity time graph to represent the movement of both cars, and Part B asks us to find the distance between points P and Q. The second question states that the velocity time graph illustrates the motion of a particle travelling along a straight line for 12 seconds. Part A asks us to find the total distance travelled by the particle, and Part B to find the displacement of the particle after 8 and 12 seconds. Okay, so let's make a start by answering the first question. Part A asks us to sketch a velocity time graph to represent the movement of both cars. So let's put velocity on the y-axis in meters per second and time on the x-axis in seconds. We'll then need to work out what velocities and what times to put on the x and y-axes. Well, we already know that car B reaches a velocity of 28 meters per second in the first 25 seconds. So we can place these two values on the x and y-axes and then draw a line to represent the change in velocity during this time. It then maintains this velocity for the rest of its journey until it overtakes car A at the point Q. And so we can represent this constant velocity as a horizontal line which ends at a time t, which is the time it reaches point Q. And so that's everything done for car B. For car A though, we don't yet know the velocity it reached in the first 10 seconds. But we can easily work this out because we've been given both the rate and the duration of its acceleration. And because the acceleration of car A is constant at 2.5 meters per second, and acceleration is change in velocity divided by time, we can find its velocity by multiplying time by acceleration. So we have 10 seconds multiplied by 2.5 meters per second, which is equal to 25 meters per second. And so we can now write 25 meters per second on the y-axis, 10 seconds on the x-axis, and then draw a line to represent the change in velocity over this time. Car A then maintains this velocity until it's overtaken by car B at the point Q, which is at time t. So we can represent this constant velocity as a horizontal line ending at time t. Okay, so we now have a velocity time graph showing the movement of both cars, which answers part A. For part B, we're asked to find the distance between point P, where both cars started their journey, and point Q, the point at which car B overtakes car A. Now, distance in a velocity time graph is equal to the area under the graph. So we'll first need to find the value of time t as shown in part A. So for car A, the area under the green lines is a trapezium. So the area of a trapezium is equal to A plus B divided by 2 multiplied by h. And so the distance travelled by car A is t plus t minus 10 divided by 2 multiplied by 25. And so the distance is equal to 25t minus 125. For car B, the area under the red lines is also a trapezium, or a triangle plus a rectangle if you prefer. So the area of the trapezium again is A plus B divided by 2 multiplied by h, which gives distance is equal to t plus t minus 25 divided by 2 multiplied by 28. And so the distance is equal to 28t minus 350. Okay, so we now have the distances travelled by both of the cars. And because both cars covered the same distance from P to Q, we can now make them equal to each other. So we have 25t minus 125 is equal to 28t minus 350. And so 3t minus 350 is equal to minus 125. And so 3t is equal to 225, which gives t is equal to 75. And so car B passes car A at the point Q 75 seconds after leaving point P. Okay, so now that we found the time taken, we can substitute this value back into either of the distance expressions for car A or car B. Let's choose the expression for car A. So we have 25 multiplied by 75 minus 125, which is equal to 1,750. And so the distance between P and Q is 1,750 meters. So that answers question 1. For question 2, we're given a velocity time graph for a particle travelling along a straight line for 12 seconds. Part A asks us to find the total distance travelled by the particle. So let's take the diagram out and then work out how to find this distance. Well, as with the first question, distance is the area under a velocity time graph. But for this velocity time graph, there are both positive and negative values for velocity. This means that the particle's displacement will be positive above the x-axis and negative below the x-axis. But for part A, we're only interested in distance, not displacement. So we can just take the magnitude of the areas under the graph. So when the particle is travelling with positive velocity from 0 to 8 seconds, the area under the graph is a trapezium. And so using the formula for a trapezium, the area is A plus B divided by 2 multiplied by h. And so the distance is 8 plus 1 divided by 2 multiplied by 5, which gives distance is equal to 22.5 meters. Now let's calculate the distance travelled by the particle when its velocity was negative, which was between 8 and 12 seconds. And again, the distance travelled is the area under the graph, which is a trapezium. So using the formula for a trapezium, area is equal to A plus B divided by 2 multiplied by h. And so we get distance is equal to 4 plus 2 divided by 2 multiplied by 3. And so distance is equal to 9 meters. So the total distance travelled by the particle is 22.5 meters plus 9 meters, which is equal to 31.5 meters. And so that answers part A. For part B, we're asked to find the displacement of the particle after 8 seconds and 12 seconds. Well, for the first 8 seconds, the velocity of the particle, and therefore the displacement, are both positive. And so the displacement is equal to the distance, which is 22.5 meters, as we calculated in part A. But for the displacement after 12 seconds, we have to consider the negative displacement between 8 and 12 seconds, which is minus 9 meters, as we calculated in part A. So the displacement of the particle after 12 seconds is 22.5 meters plus minus 9 meters, which is equal to 13.5 meters. Okay, so that's how you answer 2 typical velocity time graph questions. If you found this video helpful, then please click the like button, and also consider subscribing to my channel where you'll find more A-level maths videos. Thanks for watching.